Hello and welcome to the new episode of EBEA Consulting podcast. Today, together with Romi Singh, I will discuss applications for fast time simulation software, as well as some possible future trends on its role and further evolution. Hello Romi, thank you very much for joining us today. Even though it is not our first encounter, I am really excited to be hosting our today's conversation. And I would like to begin with your background and your aviation career. So tell us, please, about yourself.
It's a pleasure to be with you. And you and I have known each other since your university days.
Correct.
My career in aviation started even prior to university. When I was 5 years old and I saw DC-3 flying into a little airport in India. And I said, I'm going to be a pilot one day. And then I ended up in England, where I was 13 years old, and I joined the Air Training Corps in England and learned to fly with them when I was 16 years old before I could drive a car. And then I ended up in Canada when I was 17 and went to university here. And while I was at university, I also did my commercial pilot's license and put myself through university flying in the summers. So in 1969, I graduated as an engineer, and I also had about 4,000 hours as an airline pilot. I started graduate studies, but then 1 year after my MBA program, I got hired by Air Canada as an airline pilot, and I spent 32 years with Air Canada as an airline pilot. But concurrently, I finished my MBA and then did an MSc in computer science and did 2 years of a PhD in operations research. And started a PhD at Loughborough University of Technology in the UK, but I never completed that. But I did start a company in 1976 and started consulting work in airport planning and airport design. And then when I graduated from the University of Calgary with an MSc in computer science, I wanted to bring all the experience I had as an aviation consultant and as an airport consultant in particular. I wanted to bring all of that into a software that would effectively do what we're doing manually. And at that time, in the late 80s, knowledge systems were a big thing. Just like today, multi-agent technology is a big thing. At that time, object-oriented programming and the concept of knowledge systems was very big. So it was my goal to put my MSc in computer science and my flying background and my airport planning background to use to create an automated tool. And at that time, computers were not as advanced as they are today. So we started off with what they called at the time was a workstation called Apollo. And anyhow, we developed the software that was the predecessor of ArcPort. So during my university thesis, my MSc in computer science, I actually developed my master's thesis as the localization of runways in mountainous terrain, because the problem of locating a runway in mountainous terrain is actually a very easily conceptualizable problem in computer graphics. You're attempting to ensure that you can see the runway from different parts of the volume of airspace. So you're basically fitting a tetrahedron inside the contours or inside the digital terrain. And that was very much a computer science problem with clipping and seeing if there was intersection between terrain and line of sight. So anyhow, everything came together, and then in 1991, I started my own company called Aviation Research Corporation, and brought all my knowledge and background into that company, and we started to create software tools to do what I just explained. And within about 2 or 3 years, we had a tool which was the first PC based, and at the time we used what was called a 286, which a lot of people today may not know, but a 286 was a predecessor of the laptop, but it was a what they call luggable computer. It was big, but it had handles on it, and you could carry it and plug it into the mains. There was no battery pack at the time for it, but it was
Okay.
portable. In any case, we created our first software, which was a radar display for a system that would take the radar data and put it on a PC, and we could do analysis of the flight trajectories and do some noise analysis of the aircraft making noise, because we were able to couple that with the microphones on the ground. In any case, when I saw these airplanes moving around on the screen, I said, there's an application for this in terminals. And so we used the same engine that drove the aircraft as little circles like Pac-Man on the screen. And our first version of ArcPort was really called ArcTerm. And the input for ArcTerm was Excel files that were created in Excel, but we were able to track the passengers just like airplanes on the radar screen.
Okay.
So we managed to get a very nice product out, and our first customer for that was in Canada, and I was originally Canadian as well. After I moved from England to Canada, I became Canadian. So our first customer was Calgary Airport, and they used the Excel input to evaluate what they call the U.S. pre-clearance area, and they loved it. The visualization was great. They could see little dots coming to queues. They could see the little dots moving through the processors. And that was the start of ArcPort. But as mentioned, in 1993 or 4, when we first came out with this product, it was a DOS product, looked like Pac-Man, and it was originated from the radar system that we developed. And in 1996 or 97, it was such a popular tool, the terminal simulation part of it. We had sold it by this time to Hong Kong, to Rome, and to I think Leeds Bradford and London Luton Airport were one of our customers for the aviation part of it, and they eventually became customers for the terminal part as well, or the noise part, actually, not the aviation part, but the noise part. So to make a long story short, in 1997, we sold our intellectual property to the Sabre Group in Dallas, Texas. And they moved my company lock, stock, and barrel from Montreal to Texas and covered the immigration, so we became American. And we basically have been an American company ever since. So since 1997, Aviation Research Corporation moved to the U.S. and became more of an American company. We were in contract with Sabre for 5 years, and then 9/11 happened, and we moved back a little closer to Canada in a place called Point Roberts, Washington. And also, we started to convert the DOS version to Windows version. So in 1992, we came out with the term ArcPort and started the Windows version. And we did quite well with that. We sold that. At the time, we were the only ones doing the sale of a computer-based terminal simulation, and it was very good at the time, and it still is very good. But at the time, we were the only ones in the business. There were some other competitors, but there was nobody selling software on a PC that could do terminal simulation. So in any case, we had a lot of customers, and in about 2004. So we, in 2001 or 2002, after 9/11, we came out with our Windows version. And also in 2001, Sabre was no longer interested in staying in the airport business with the software, so they sold it back to me. So I was in the U.S. at the time, so I maintained the U.S. company, and the U.S. company then developed the Windows version, and we opened up an office in Shanghai, China, where my partner at the time was a Shanghainese. He did the development work, and we hired some staff in Shanghai. And to this day, that team is still in Shanghai. But of course, my role has changed. But we sold the Windows version of ArcPort to many customers. I think we had the largest market share at the time because we didn't have any competitors. And then in about 2004, 2005, the British Airport Authority, who at the time ran 6 airports, we had approached them a couple of times to sell them the ArcTerm product. And they were very interested, but they had to go through some kind of a process for purchasing because they couldn't buy sole source. So they got their IT people involved, they got their finance people involved, and they came out with a tender. And in that tender, they asked for a lot of detail of how the product worked. So I put together a 300-page document that described every aspect of ArcPort. And we submitted this tender, but the people in finance at the British Airport Authority, they had stipulated that any company supplying products to the British Airport Authority must have a Dun & Bradstreet rating and must have audited financial statements. Well, I owned the company, and I was an Air Canada captain at the time, and I didn't need audited financial statements. I didn't have any. So after we submitted the proposal, we got disqualified because we didn't meet their financial department's regulations. Mm-hmm. So we lost out on that BAA deal, but what BAA ended up doing was contracting with T-Systems, who in turn contracted with the Airport Research Center, funnily enough with the same acronym as Aviation Research Corporation. And then about 2005 or 2006, the Airport Research Center came out with their first product called COST, as you know. And they sent CDs to a number of customers, of which Toronto Airport and Seattle Airport were a couple of recipients. And they came back to me, and they were our customers already for ArcTerm, and they came back to me and said, "Hey, this looks just like ArcTerm." And I said, "Wow, that's interesting. We lost the bid for the contract with BAA, and now they have a competing product." Well, we thought about legal action, but we couldn't because I wasn't rich enough to go into courts in England. And so I decided that we just make ArcPort much better and stay ahead of the curve and stay ahead of cost, which we did very successfully. And I think to some extent we still are doing that. But a lot of competitors came up along the way. You know, it's like pizza business. After the first one starts, everybody wants to get in the pizza business. So a number of customers came along, including the generic products like Arena and Simeo, and there was several universities that as research projects started to do simulation work. For the longest time in Amsterdam Schiphol, the university in Amsterdam was supplying them with simulation software for terminals. And so we didn't make any progress there. We have customers, for example, NACO, who is doing extensive work for Amsterdam Schiphol with ArcPort. But in any case, we ran into A lot of the corner pizza businesses that promised to be able to do simulation. In fact, I have an interesting story I can tell you about Dusseldorf. We went to Dusseldorf in 1997 or 1998, and introduced them to the concept of simulation. And there's a 1 hour presentation where my presentation was with the DOS version. And they introduced me to the group of people there, and there was a professor from a university there. And I asked, what's the professor doing here? And the people at Düsseldorf Airport said, well, he's going to advise us on whether we should buy this tool or not. Mm-hmm. And I said, okay, that's fine. So I did my presentation, and about a month later, I called them back and I said, so what do you think? Should we come and help you to establish your facilities using this simulation tool, or can we sell this to you and train you? And I was very surprised with the answer. He says, Professor, whatever his name was, he said, you don't need to buy this. Our university can do this all for you. So they went with the Düsseldorf University for the longest time. And then, of course, when they realized that the university couldn't produce the tools that were out there, then they decided not to do that. And about 8 years later, they ended up buying CAST because the university was not able to give them the kind of service that these modern tools do. And today, on the market, we have a few tools like ArcPort is, of course, the pioneer. Mm-hmm. So that brings us to where we are today. In 2016, I had a great success in marketing and developing and selling and working with ArcPort. But I turned 70 in 2016, and I thought it was time for some succession planning. And I had a very warm relationship with Milton Carrasco, who is the owner and CEO and president of Transoft Solutions. And he had actually been a very congenial and close friend since 2004, when I had a heart attack in England, and he agreed to take care of my family and the software in case something should happen to me when I was in surgery. Well, fortunately, I came through surgery quite well, and my heart attack was just stented, and I've been very healthy ever since. But since then, Milton Carrasco has followed my progress, and I followed his, and he's been an inspirational leader. And so in 2016, June 1st, I signed all my intellectual property over to Transoft Solutions. And I contracted with them to remain with them for at least 3 years to transfer the technology and help them integrate ArcPort into the Transoft portfolio. And they did that very well. And the head of the aviation business unit was Ben Van Leest in Sweden. And he and Milton, they both embraced not only the ArcPort software, but they also embraced my entire team, of which I had about 8 or 9 people in Shanghai. So they took over the whole company, and they contracted with me to provide this service. And they've done an excellent job of marketing ArcPort, of enhancing it. And of course, you may or may not know, but Transoft is a world leader in solutions for engineering and civil aviation software for transportation. And they have something like 30,000 customers, and they are a very reputable and fine company.
We at EBEA use ArcPort to support our projects and analyses with fast time simulation, so it's really interesting and great to hear about its conception, Evolution, and finally the transition to Transoft, with whom we also work. Now we can move on to fast time simulation applications. So could you please tell us what the key benefits of using fast time simulation tools such as ArcPort are?
With respect to fast time simulation, let's look at the real world. We're going to build an airport, as an example, that will run for 30 or 50 years. And maybe we'll take a look at 1 year, and we want to know what the level of service is going to be on the busiest time of day, on the busiest day of the week. And we might consider, for example, a Friday afternoon. And we'd like to make sure that there is an adequate level of service. Well, if we look at the real world, every Friday is not going to be the same. Sometimes it'll be high level of service, sometimes it'll be a little bit less. For example, the number of people in the queue could vary from one Friday to the next at the same time, given the same schedules. So we are interested in knowing what happens across a large period of time, or a long period of time, or over many cycles. So in engineering, we talk about the cycles. An airplane, for example. An airplane takes off and lands and goes through many cycles of compression, decompression. And the fuselage had to endure this stress of going into different pressures. So in the same way, they test the cycles of the airplane by making go through a fast time simulation, by putting in a pressure chamber and stressing it many times to go through the number of cycles. In the same way, in the airport design, we can go through many, many, many days of simulation to test to see what would happen over many Fridays, for example. So the fast time simulation gives us a way of testing how the airport would behave over long periods of time, and allows us then to determine a distribution from which we can make statements such as, nobody will wait more than 10 minutes 95% of the time. But maybe 1% of the time, they may wait as much as 25 minutes. So this is the reality of what fast time simulation can give us. It gives us the ability to test the future performance today very cheaply without impacting people in a computer. And I mentioned the challenges of developing the fast time tools. When you're creating a version of reality in a computer or with an analog model, you can't capture all the realities in the model. There are many unknowns, and you can't capture all of them. So by necessity and by definition, fast time simulations are approximations of reality, and they are random in nature, in the sense that the variables that you input and the variables that you define and for which you input data, they are random variables. So data becomes a key issue in the development of fast time simulations. And when we talk about data, it's not just identifying data, but it's how to secure it and how to process it to input into the simulation model so that we can represent the reality to some degree of accuracy so that our results would be accurate. And of course, there is a whole study that encompasses the art and science of data collection. So you identify the variables, then you collect the data, and then you process it to put it in a form that is palatable by your simulation tool. So the steps in the fast time simulation are not just writing the software, but it's an entire way of thinking about the real world phenomena and how to model them and how to get data that you can use to drive these models, and then the results, how you interpret the results. We have people out there who are throwing out numbers and saying, for example, the runway capacity is so much, the terminal has so many million passengers per year, and essentially that is not correct, because these variables are random numbers, which means that they're represented by a distribution. One day you might get 30 movements an hour on a runway, and the next hour you might get 32, and the next hour you might get 28. So in fast time simulation, we have to take into account what is the distribution of the input variables and also the distribution of the output variables. Okay, and of course, sometimes this is not always clear. Now, you've asked me about fast time simulation, how it's been added to the IATA's ADRM documentation, and it is to support master planning exercises. Well, myself and my colleague Miguel Bonatur, as well as Ben Van Leest, we were contributors to the version 11 of the ADRM, and one of the biggest problems with the master planning exercises which have been developed over the years has been that they have used statistical numbers to size the airports. And they use the peak hour flow, they use the 30th busy hour from the past, and they calculate space requirements with the average dwell time and the peak hour flow. Well, that formula comes from hydraulic engineering, where you have flow, which is a rate per hour, multiplied by dwell time. It gives you the number of people. Well, unfortunately, in the real world, that is not how it works. In the real world, the number of people in an area depends on the processing time and the things that they do. And it is not possible to capture that in the formula. So the challenge today for the master planning exercises is to use a flight schedule which shows you the actual demand. Because the actual demand is not so many million passengers per year. The actual demand for an airport is the schedule that's going to operate that day and the people that are going to be on those flights. So the real demand for an airport is not millions of passengers per year or the peak hour. The demand are the specific flights. Because in a peak hour, you can have one 380 that generates 800 passengers, or you can have 15 CRJs that generate 800 passengers. So the shape of the airport and the terminal is going to be very different depending on which one of those two, but they both have the same peak hour flow. So anyhow, so the IATA ADRM is a very useful document to document the different ways of doing things, but there are issues that we've had to address. And one of the key issues has been that most of the master planning people don't understand that the airport operates with a flight schedule and not with a formula. And that has been our challenge, and that is where we've made the most progress in showing people. And I think that's one of the reasons why IATA has now stipulated that they should use simulation, because that is like running the real airport. You have to have operational strategies to run the real airport, and master planning exercises have traditionally not thought of that. So I think that the current thinking is that you need to consider how to operate in addition to just sizing the airport. And we've had several exercises over the last few years where we've come head to head with planners who don't understand even simple things like repositioning aircraft for different sectors. For example, we have aircraft that come in international go out domestic, or they have aircraft that come in Schengen and go out non-Schengen. Well, unless they have what they call swing gates, they have to move the airplanes around. And in our experience, many of the planners have not thought of that. So they come out with a number of gates based on a formula, but the flight schedule doesn't fit those gates. So that results in problems. So we've had to address a lot of issues that have come out as a result of the requirement for simulation to support master planning exercises.
Now, this is the end of the first part of my discussion with Romi. Thank you for listening, and please make sure that you come back next week for the season's finale of EBEA Consulting podcast, where together with Romi we will continue to discuss and talk about the industry trends. Thank you and goodbye.